Hi, we are Team BioShield, and today I'm going to be going over the manufacturing processes that we did during our project for upper extremity osseointegration protective cap. So this video is showing our very first manufacturing process where we molded one of our team members' elbows. Molding was a big part of this project, so we were just trying to practice as much as we can because we took several molds throughout the year. So it changes color when you know it's about ready, and you hold your limb in this Luna Beans molding kit that's available on Amazon. And once it dries, which is pretty quick, you can pull your arm out, and it leaves a nice imprint, and then we poured stone into it to make that. And it's a really accurate mold, actually, for our first one. From there, we did a silicone mold. And as you can see, it turned out pretty well for our first one. We then did our carbon fiber layer, which we had to work a little bit on developing it because it was hard to remove, hard to get it in the right shape. But then we worked on the interior side of it. So this is our very first prototype. That's our second one right there, experimenting with different foam sizes and paints. We also tried to make a testing fixture out of air dry clay based on this 3D image that we got. Didn't turn out too well, and unfortunately due to COVID-19, I wasn't able to develop it much more. This is his attachment piece that we needed to use during the project. This is us also working on the test fixture in the machine shop. We recreated the attachment piece for our Challenger's arm using 3D printing. So here's some of our 3D prints that we did in EIS 106B. Some of them turned out better than others. And we used the 3D prints for our carbon fiber overlays with epoxy resin. It took about a night to dry. Here's a picture of the 3D printers actually working for a short period of time. We had some issues during the year with them. Unfortunately, most of our prints took about 13 hours. So when they failed, it was overnight, and we didn't know until the morning. So this is a JB weld that we did for the spring assembly that you can see here that goes inside of our prosthetic. It sits in there kind of nice. Yeah, and this is it pushing out the attachment piece that we 3D printed. This is the foam that we used. It's actually used for squishy toys for kids. So it's safe to handle. And it expands 15 times its poured volume in a matter of about 45 seconds. So time is of the essence. You can see in this video, it's expanding very fast. But this is the result before we cut it. It tends to be taller on one side. We also did some testing. Since we were at home, we used our home oven to test it for extreme temperatures. It did really well in all temperatures. No cracking or anything like that. And the spring assembly still worked. No melting, as you can see. We also tested it in the freezer. We were only able to test it at 0 degrees Fahrenheit instead of -30. We did a drag test where we took silicone and placed it on a surface and put a small weight on it and dragged it with about 5 pounds of force. And this was our first snag test that we tried, but as you can see, our object is not a perfect cylinder, so it didn't roll nicely, so we had to use a different kind of test for that. Here's another drag test. So yeah, thank you so much for watching our video, and if you have any questions, feel free to ask us at Design Day.